So today we will do basic Android pen testing, and we'll start with understanding AndroidManifest.xml. Let me real quick fire this up, and we've got. So I'll just authorize this lab. An Android application APK is provided in this lab. Use apktool to extract the package, analyze AndroidManifest.xml, and answer the following questions. What name? We have flags in here, all verified. What is the name of the application, the version of the application, this on which this app was compiled, how many permissions elements are present in a file, is it possible to take a backup of this application via ADB. The application has a service. Can this service be invoked by the component of another application? So, and we have manifest developer Android manifest. So this is how it looks. Manifest, application, activity, and activity name, intent filters, permissions, Android permission, send SMS. Okay, so we have Groovy and we have Kotlin. Groovy, Kotlin, Groovy, Kotlin. Okay. So those are intent filters, edit, insert, delete actions, drawable small picture, applique, declare the application category of the intent, comparable data specific in intent filter, grant URI permission, specific subset of app data that the parent content provider has permission to access. Instrumentation class that allows monitoring applications interaction with system. Manifest metadata, path permission, grow, permission tree, provider, uses library, uses native library, specific vendor, use permission, use SDK 23, specify that app wants to a particular permission, but only if the app is installed on the device running API level, and uses SDK lets you express an application's compatibility with one or more versions of Android platform by means of API level integer. So this looks like this. Application Android low backup. This is a low backup. Okay, name launcher. Okay, let's return to the lab, see what we got. apktool. I will copy some. I want to make dir test cp sample to test, enter the test, and apk tool d. to unpacked. Okay, and we jadx, we don't have it, so we can see what we got. cd sample, and we have unpacked Android. Let's not found. More than new, less. So we have Android SDK is hard to see it like this. Cut. So we have Android SDK sensor compass required true permissions 1, 2, 3, Wi-Fi start, find location, course location. Okay, so the questions that we have to answer. What is the name of application? Name of application is name of application. Haha. Launcher, name activity, do Android name, reservice, nope, access network. Oh, we have another one. Okay, let me grab real quick name, and we have names. Name, nope, name, Android name, app name. So we need app name in the strings. Okay, app name in the string. Grep app name, the app name, raise values, strings, on crackable 1. This is the name of the app. Uncrackable 1, name of the application. Okay. Now what is the version of SDK on which was compiled? Let's return real quick to the Android manifest and SDK compile version 23. Okay. How many permissions elements are present in file? Real quick. Permission 1, 2, 3, 4. Okay. Is it possible to take a backup on? So we are looking for backup. Backup. Allow backup to launcher. Okay. Backup tool. It is. In the application has service. Can this service be invoked by components in the other application? Okay, let's look service, and we have exported through, enable to exported through. Let me find real quick service, and we need exported where the component of the other application can invoke the service or interact with it true. If they can, follow. So yes, can be invoked by another application. This is it. This is all of the lab within Android Manifest. Let's proceed to another lab. So we have the next lab, that is bet permission 1, and we have Android mobile application need users permission to access different resources or to perform restricted privileged actions. Those permissions are listed in AndroidManifest.xml file, which is packaged in application APK. One of the telltale signs of the malicious application is that they have permission irrelevant to their advertised purpose, e.g. an alarm app with permission to send SMS. With in this lab, you have provided with APK, or provided with APK or the heart rate monitor application. Use apktool to extract APK and analyze Android manifest file. Analyze Android manifest, identify unnecessary suspicious permissions. Okay, so we have this one, APK sample, APK tool for decode. By the way, APK can be mkdir test cp sample APK monitor to test. And if we change wait a minute, let me file this one. We have zip archive, so APK is zip. If we change sample APK to sample zip, we can unzip this one. We have gunzip or unzip file. We don't have it. So okay, so we have 7-zip extract and done. 7-zip help. So X is for extract file full pass. Okay. Now we have the same things that we have with the APK. Slight difference is that we don't have classes decoded. Slight difference. So sample monitor cut Android grip I permission. Let me minimize it, and we have Bluetooth admin, set debug app, wake lock monitor with set debug app. Why do we need to debug app, and why do we need to be admin on Bluetooth? I don't know. Let's find out. Provide full permission string, Android wake up lock. So my guess is this is the baby. Let me see. Yep, and this is it. Set debug app. We don't have to do the debug app. So now we can cut same test and do grep with I permission. Okay, so it's not that grep I okay, I can get permission. I'll just Android XML. Cool. Okay, that's it. This lab is done, so we will proceed to the next one. This one can be a little lengthy. Bad permission part 2. Android mobile applications need users' permission to access different resources to perform restricted actions. Those permissions are listed in Android manifest. Okay, this is the same as before. In this lab, we are provided with APK ahead rate monitor. Okay, so now we have the aapt Android asset packaging tool to extract the permission from the APK. So this tool mostly is compiling, packaging, and linking the resources. So now we need to do the reverse operation, not compiling but decompiling. Let me see if there is decompile option. Or dump, maybe dump diff convert dump syntax sub. Okay, what's dump? It use printing information about generated using link. Nope, it's not that. apk2. So we have many tools in here, but decompiling is not an option. Okay, then apk compiled, link, diff syntax, optimize, convert, time and mode, version, convert, apk command, compile resources, binary, convert, output, option files, apk, format control. Suitable for APK. It is possible also specify pro buff version. No, it's not that. So we have compiled in here. These are all the resources. Pass to file. zip trace generate. Nope. Let me check this one real quick. So it is indeed dump. We can dump the general subcommand, and subcommands we have strings, resources, XML string, XML3, APK. Okay. So let me check this one real quick. We have apt2 dump permissions form sample unable to open permissions. Whoa. Okay. 2 is not capable of doing this. Okay. 1 is capable of doing that. So we have permissions. Internet access, network, get accounts, use, wake up, write external storage, C2 permission, receive, C2BM, dump, and camera. And we need full permission string. What mission is identify unnecessary suspicious permission. Well, my guess is dump is little fishy. I guess. Yep. This is it. So we can proceed little bit and see over the label package name. Okay, let me play with this one a little bit more. Strings, we have all the strings of, here we go, verify, enter secret string, special things for da 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 da. Okay, let me package name on it. Package name. If I can write package name. Okay. Package name. Unknown option. Let me see options on this one. Dump, help, subcommands, maybe. APK remove add quench. Okay. So this APK has strings, bandit, permissions, resources, configurations, XML strings. We don't have any package name. And what about second? Dump option file. Okay. Compiling, optimize, no. So we can do dump XML strings on this one. No dump XML. Okay. Tree resource specified. Strings print given XML asset. String resources permission resources. All configurations also in testing. Configurations. Okay. Resources. Resources. Whoa. Resources. String action. Public. Okay. We got something to work with. That's it. This is the lab, and we'll proceed to the next one. So this time, BAP permission part 3. Android application, we already know that there are some permissions in the Android manifest that are fishy or irrelevant to the advertised purpose of the app. So in this lab, we have APK of a footstep counting application, pedometer application, and with help of classy shark we need to reverse it and analyze AndroidManifest.xml file and see the unnecessary or suspicious permission. So now we have desktop with the classy shark jar, and beforehand I think I want to understand what is classy shark. And classy shark is standalone binary inspection tool for Android developers. It can reliably browse any Android executable and show important information such as class interfaces and members, tags, counts, and dependencies. Classy Shark supports multiple formats including libraries, text, IAR, SO, executables, APK, jar, class, and all Android binary XML, Android manifest, resources, layout, and so on. So to run it, to grab it, we have the jar in here, and to run it we need to java jar classy shark. Let me run this one real quick. Java jar and edit real quick from 10 to, let's say, 40. So we have jar desktop classy shark. Meanwhile, let's go and see the guide for this one. And here it is, the guide. So we can open archive, browse, clicking, and doesn't stop APK, but actually see the text. Files as class jar. Browse components. We can right click executable, see panel components and APK, inspect package, count multi-dex. You can activate simply, okay. Incremental search, so we can search this one and click navigate class. Well, you do not have to. Class is a handy search field that you can use to filter classes by writing matching queries. Okay, native code restriction is read it, and we have also learn more APK class teacher. Okay, and we have also command lines. I'll just run it, and we have API in part doing explore. So open APK. This is how we open it. Open binary full qualified class name. This is a full qualified class name. Export, and we can export this one. Analyze APK and dump out following files. Export binary full qualified. So we can list all the classes to have names and signature of all method indexes, strings table, all strings, index all string tables, and manifest go without saying. Method count, human readable, so we can count them. Dumps all the packages tree with packages method counts. So let me, okay, hello there. Let me play with this one real quick. Where do we have sample pedometer, and we have text classes as guaranteed, as declared, nothing too fancy. XML with layout, and let me see manifest real quick. Read attachments, read contacts. Read attachment or read contacts is necessary permission for the pedometer application. What do we have in here? Dark mode, light mode. I guess this is the history tab. This is export tab, but not seeing it working. Import Pogard mapping file. Okay, and we can open this one. Fine. I want to export this one, and any changes in the output? Sample, nope. No changes. Okay. Passing class. Count txt. Oh. Let me see this one real quick. Maybe I do have this. Okay, we do have this. Cut all, no matter what, txt, and let me less. So we have class names, we have path, we have something that looks like base 64, up debuggable, we have strings and path for the packages, root detected access. Okay, even binary. Cut method count. Ooh, nice. SG 0.13 for uncrackable. Why do I don't see any. Oh, this is it. So let me check this one real quick. I guess, or read contacts, or read attachments. To permissions that, in my humble opinion, are not necessary for this one. Strings. Strings. Oh, strings. Wait, what? Okay, and dump. What is dump? Permission, not permissions. Permission. And or it. Okay, so read contacts. I guess read contact. Nope. Then next one will be email. This one. Okay, this is it. This is the permission that was supposed to be there. I'm pretty sure that contacts are also not needed, but let it be so. this is it. I think we will proceed to the next one. So this one is permission part 4, and here we have new tool, jadx-gui, to reverse the APK and analyze Android manifest. We need insufficient or suspicious permission, same as before. So jadx-gui Java jadx-gui, maybe. Yep. The compiler. We do have so text to Java decompiler, command line GUI tool for producing Java source code from Android text or APK file. Please note the most of cases it cannot decompile all 100 of the code, so errors will occur. Check troubleshooting guide for workarounds. Decompile Dalvik bytecode to Java classes from APK text IAR, AAB, and zip files. Decode AndroidManifest.xml and resources from resource ARC SC. Obfuscated included. Though there are some features, we can see GitHub, GUI, Pacman. Okay. So now we will open the we do have sample. We don't have any sample. Dude. We cannot. This tool is already not seeing APK file, so I will copy sample to sample zip and we'll try to load zip. Okay, now it's working. Let me see. Maybe I've just used the wrong one. Nope. Okay. Java decompiler. I don't see that it's working like it stated, but jadx-gui, maybe I've just picked the wrong one. Yep, I just picked the wrong one. So now we are talking. APK signature. Okay. Resources. Now we have it. Nice. So we have the R class with some resources, values, another string one, uncrackable one, verify with menus is empty, styles is also empty, classes ticks, text A. So we have secret key specs within the A. We have flux checking within the B. We have some checks that this file is doing. And we have the main activity. Success, this is correct secret, and string decode base. Okay. So back to our questions. Provide full permission string. Permission that is irrelevant for example for the game. So internet is good. Access to network, manage accounts sounds not so relevant to game, for game to manage accounts. Yep. So manage account is not the best permission that we need. Bad code imports, obfuscate. Use copy method for the var names. Remove flags. These ducks jadx knows how to work. For sure knows how to work. So I guess we'll just finish this one and we will proceed to the next one. So bad permission part 5. We have the same exact text that we had in every other part, but now we have new tool, mobile security framework, MobSF, to analyze the APK. So it looks like this. We have the site, so I will drop in here the APK that I've just downloaded from this link or this link, and I will return when I have some results. So while I'm waiting for the mobile security framework MobSF analyze the APK that I've uploaded, we just get to know this framework a little better. So MobSF is an automated all-in-one mobile application, Android OS, iOS, Windows, pen testing, malware analysis, security assessment framework capable of performing static dynamic analysis. Okay. MobSF supports mobile app binaries APK, XAPK, IPA, and IPPX, along with zipped source code, and provides REST API for seamless integration with your CI/CD or DevOps pipelines. The dynamic analyzer helps you to perform runtime security assessment and interactive instrumented testing. So we can pull it from the Docker pull Open Security Mobile Security Framework latest and run like this. And we can learn little more about it. Island certification courses, free support. We can see how it looks when it static analysis, Android source tree view, iOS, APK, web API viewer, and that's it. I think very good framework, and we have our APK analyzed, and we can start answering questions. I don't think we have too much, but provide full first permission, second permission. Okay, so we are searching for permissions. I guess permissions, if we click on this sidebar, we can navigate through the binary code, security analysis, manifest analysis, code analysis, file analysis, malware analysis, reconnaissance, components. We can see files, we can see providers, services, not too many, but media parsing, download the report. I don't want to download it. Start dynamic analysis. I didn't try this one, but I think it is also good. We have some sign certificate. We can see the information about it also, and we see the permissions. Most of them are dangerous. And let's see what video player. So video player, read logs, I don't know, vibrate, okay, internet, receive, boot, completed, okay, audio, okay, network access, modify audio settings, send SMS. Most certainly this type of application don't need to send any SMS at all, or call phone. Directly call phone numbers, send SMSs. It's not his job to send SMS or call phone and make phone calls. Okay, so this is it. We can get through this one, see what we have in here, read some description, understand what issues are there with our classes or services or broadcast receivers or whatever. If we have some kind of CWEs, also we have one in here. Upload information sensitive should never be logged. So, and we have the score that is pretty high. So we have app may request root super user privilege. It is also not good. We can try to see what. So string mention keys su is indicates that indeed this app can ask for super user. Okay, su super user. Okay, let me see this one. We have some kind of code in here. So this is it, and we'll proceed to the last part of this lab. So the the big boss of this Android Basics Pentest labs, reverse and patching APK, reversing and patching. So we have the lab focuses on doing Android APK analysis using different basic tools. An APK is provided in lab. Perform the following activities. Scan APK with Super Android Analyzer tool and identify the issue, which allows anyone to back up your application data via ADB. I need to see what ADB stands for. Open the APK archive using apktool. Fix the issue by modifying the corresponding file. Repack the file into APK archive. Sign the APK using jar signer. So we have Super Analyzer, uncrackable level 1, and we can see what do we have in here. Uncrackable level 1 APK. So, and Super Analyzer is a command line application that can be used in Windows, Mac OS X, and Linux that analyzes APK files, searching for vulnerabilities. It does this by decompressing APK and applying the series of rules to detect those vulnerabilities. But why create a new analyzer is not enough? Is not enough with MobSF, Quark, and bugs? I will search for those and we'll look into them too. Well, we think it's not enough. All of them have two main issues we wanted to fix. They are written in Java or Python, and they are not easily extendable. They are not meant to be used by businesses directly working in Android analysis and do not put that kind of functionality first. Our approach solves those issues in different ways. We first decide to use Rust as our programming language. The language developed open by Mozilla Foundation gives us a lot of utilities to work with regular expressions, file, etc. And most importantly, it enables us to create a secure software that does not depend on MVM or JIT compilers. With Rust, Stack Overflows, segmentation flow, etc. are directly not possible, which makes sense in security-centered application. And it also gives us enough power to do efficient analysis, give us the option to automate it in high volume. This is given by Rust Zero Cost abstraction that gives us an efficiency only comparable to C++. But Node requires Java 1.7 plus to run. Funny. Still it requires Java to run. And secondly, we decided to make the software 100% extendable. All rules are centered in the rule.json file, and each company or tester could create its own rules to analyze what they need. It's also modular, so that new development can easily add new functionality. Finally, the templating system for result report gives user the ability to personalize the report. Let me see those rules, results. I don't see rules as was stated. Rules JSON. Nope. No rules JSON for your build. Nope. Spec. Name template bash. Okay. Nope. I don't see rules, and I already started to JSON. Rules JSON. So we have schemas. We have URL disclosure. Regexp. Regular expression. All they are using versus source code IP, math random method, unchecked output logs, weak algorithms, sleep method, war readable permission, and so on. SMS messenger, medium, super user privileges, high get cell location. I don't like this permission also. GPS location. With knowledge base 64 using encoding not secure method for data. Looks legit by me, and it is good that I can extend these rules. Looks legit. Okay, so we have this analyzer, and we can super analyzer. Let me check real quick. How do I fly? Quiet test all version next to analyst download. I will take test all. Is downloads directory. Test all APK files in the download directory. What? Okay. So I don't need test all. I don't see any show benchmark for analysis. Will I force help GUI the boss downloads rules path options? Let me see. Start in analysis to uncrackable 1. So let me see, what do we have in here? List and results. So this, I guess we have it unpacked, of course, and let me see results. So we have menu, main activity, HTML, layout menu, Java HTML, everything in HTML. Okay. The problem that I'm using CLI, so HTML would be no. Do I have JQ? No. Okay. So we have, it's good when we have no HTML. So generates HTML report power once. I think I had to do it JSON, Flux JSON. Let me rerun this one real quick. Okay, good. Test cp uncrackable to test cd test, and now super analyzer JSON uncrackable test, and now we report generate, JSON report generate. Okay, JSON. So now results, here we go. Got no, more without JSON. Whoa. I don't know what's, maybe the first one wasn't bad idea. The problem is that I cannot open index.html, but I can search. Let me search for this one. Dude, it's, let me return real quick. I've just done a slight deviation from the original lab because I cannot. What? Okay, I need to download executable of some kind, but see that it is not. You will need Rust compiled from source. Dude, I don't know. Okay, this is it. Release echo. Okay, so I will cd to opt and hope that it won't take much space, this one. Fixed, no, fixed, 14, okay. So now, up, get clone this one. Done. Super. So, super. And we Ubuntu. What? Cargo env. Okay. That's it. Installed cargo real quick. Cancel installation. Stable, yes. Well, you can uninstall. Gun installation options. Okay. Wow, this can take a lot of time, so I will return when it's done. So it's done, and we have to source home env like this. And now I can finally super no such directory. Okay. Super. No such directory. What's in Ubuntu? Source cargo env cd. Okay. Well, I will create this one. mkdir raw super. No such depth. Do you mean be view install? We what? Cargo div v. Cargo div v. Build packages. Okay. Maybe cargo div v. Install cargo div. Okay. So these. And now okay, I will return when it's done. Taking too much time, but like always, low disk space. And I'm waiting for last package to be compiled on a cargo dip. And then when you have cargo dip, you can cargo dip run this. So that's it. Now does not exist. Cargo tool does not exist. Dude, if you are doing something, just do it like it. What's cargo tool? What path? What path is not existing in here? Target Debian Super Analyzer echo release Super Analyzer. I don't understand what this one is talking about. Deep cargo metadata manifest does not exist. Why manifest does not exist? Cargo total. Manifest path does not exist. Okay. Does not exist. Rust src. What I'm missing. Pass to get a source. Not find. Manifest path. Pass to. Okay. Then cargo tool 1. Ubuntu build. Deb v release cargo deb not deb fast new cargo frozen path first pass. Okay, cargo manifest path. Opt super normal. I guess this one has to solve the issue. Okay. Now the issue will be with the low disk space. I think meanwhile I can pull request if they don't have some misuse, unknown file format fails. Trying to strip unknown file format. New rule, new document. Nothing about dependencies. Java dependencies. No. Add test manifest. Automatic downloader or source view. Page. Five. What was the currently the name of this for manifest? There is no tests. Okay, no, it's not if. Too many password roles or automatic downloader. Bunch of warnings. Let's hope that we don't have any errors in here. So I hope that this analyzer is working. And let me check real quick on Crackable 1 GitHub. This is it. Download this one. We have it. CD to download. Nope. Oh, super. Target. Release. Super. Uncrackable. Error. Super doesn't exist in templates. JSON does not exist. Okay. Templates. So let me try to go to super and copy from target, release, super, super analyzer to here, and from here maybe root uncrackable. Oh, now it is working. Okay, now it's working, and we have, what do we have in here? Report. But for some dumb idea, we have this and result in here. Okay, let me create folder with this and open another window. Open super, and we have this and we have results. Let's drag it in here, and for now that's it. Now this super analyzer we can have N, I think S, nope, S is symbolic link, target link name. Okay, so LNS target link name, user bin super analyzer, and now super analyzer I don't have it. I had to do not symbolically, hard link. Hard link, symbolic. Do I have this one? Super bin super analyzer. I don't. What did I miss? Super. Super analyzer. Layout, symbolic. Sim link. We see hard link. Node hard link, file name node hard link, node symbolic link. Okay. Linux and N command create symbolic link. Option file link. Okay. Source file symbolic link. Link. I don't know. LNS dot super analyzer user local bin super analyzer which. Okay, so now super analyzer can be run from here and it is working. Okay, so now let's analyze this one. We have results and we have them in HTML format. Here we go. I don't know why previous lab was command line. I don't have anything to do with the command line, with all due respect. But to see this, I need to have some GUI. So we need to see root and device detection, application perform checks for rooted device. We have this affected code. We have allow backups, medium critical vulnerabilities. we have super privileges in here, low criticality vulnerabilities, and that's it. Check source code. Very nice. So now I guess, wow, very nice, very nice. I don't know, I cannot scroll too much. Yeah, here I can scroll, return to report, and I have code. So what do I need to do in this one? I have so we have reverse it, and we have apk jar signer. Let me see what do we have in here. So I've just unpacked this. So the return to this one, high criticality. What do we need to patch? Maybe we need to patch the ability to backup. So I can now do the APK. So now that we have APK, we can copy to reverse. See what we got here. apktool the change ability to back up. Folder. I want to open this one, and we have let me change allow backup to false. And now we need to pack it. Repack opened files, and we can provide us with repackability, apk decode, build. Okay, build. So now apk to be this one. First type is not auto. What's that? First type is not auto. So we have could not exec version name, meaning. Let me remove APK real quick and do this one. We have build. Nope. Let me try to rebuild this one. apt first type is not up. Exception. I don't know. What do you mean? And we have no. We have build, but we don't have destination. Okay, first type is not auto. What is it? apktool error the update empty framework dir. Try to clean. Solve the problem. Okay. Removing APK. Okay. So let me return to the previous one and let build it again. First add the nope. First add is not. So we have local share APK framework REST. Framework empty framework here. Let me see, one sec. Root local what share apktool framework let me see. Okay, no, first type is not. Defaulting could not extract pre-built app could not extract. Use apk let me see this one. Include structures here. D without changing anything, yes. B dirty. Remove, auto remove. Okay, let's return to this one. So basically what I need to do is to apk uncrackable. Okay, go what's within the test. Oh, cd test. So apk tool the uncrackable. Now we have unpacked this one, and I will nano AndroidXML and will change true to false. XY. Now I have to remove uncrackable APK and APK tool be uncrackable APK and hope that this one is working as it should. And now we have uncrackable will be dist. As dist we have new uncrackable, and now I can reanalyze this one. I will copy uncrackable this uncrackable in here, remove this from here and results from here. Okay, and now super analyzer uncrackable APK search for nano results index and we total found vulnerabilities 5. Well, I will grep I backup. Hello backup false. So, well, I think that we succeeded in changing the backup to false in this one. Now we need to, I think, kgen this one. How do we jar signer help jar signer help key store, password, key store. Okay, so we need, I don't know, this one to Android key signing up without signing key. Okay, so sign up your key, sign up your key, APK. So upload key, signed user name. How do I create this key? This is the question of the century. Key to export FC key store, your upload key store J alias file. Okay, Android step-by-step guide, signing keys. So key store Jan, key store, okay, size, developer name. Very interesting one. So let me just copy this one. I've just desktop keys. I don't think this one is good, but let me key store, and now let me do these keys JKS. What? JS. So key store J. Key store like we thought in here. Let me change it here. That's it. So this will be here. JKS store JKS RSA developer name reader ser dev. That's it. Here we go. Password. Too short. Okay. Last name. The organization unit and the name of your organization, rev dev ops, city location, local host, state province, HTTP, two-letter of country code, HL, HR, HR, LHR, correct? Yes. And key password for revdev. We enter. So, warning. I have key. Okay. Now that I have key, I need to sign this one. Key tool. Nope. Jar signer. Android app jar signer. Okay. Stack Overflow jar signer. This one. Key application name alias name. Okay. So I will take this one up until here. Up until here. Yep, up until here. Now I will play with it here and key store. I just key JKS. My application name is this is it on Crackable APK and on crack me alias key freeze. Wait, what? Chain not found for alias master first valid key store. I don't see any key store. I'm missing key store JKS. Okay, let me check this one once again. Certificate chain not found. Okay, let me play this game once again. Validity alias revdev. Okay. Oh, maybe I just messed up with alias. I had to do rev dev, I guess. Reverse there. Okay. Now this one has to be right. Yes, that's it. So this alias was for the key, and here jar signer has to be for the key. Yep. To Facebook. So alias name for the key. Okay. That's it. I think we've got it right. And for now, all these labs are finished. We need to so basic Android pen testing labs are finished. So long. See you in the next one.